we have to find tie-set matrix corresponding to this coupled circuit. Okay, if we want to find tie-set matrix for this network, first we have to draw the graph of this network. Now, how to draw a graph? If you have voltage sources, short circuit these voltage sources, and if you have current sources, open circuit current sources, and if you have any elements like RLC elements, represent with a short circuit line. Okay, this is the procedure to draw a graph. If you see here, there are two nodes. Okay, here we have one element and voltage source. Okay, let us take this as first branch. Similarly, current flowing through this branch is in this direction. So, okay, let us consider this one. This is node 1 and this is node 2. Between node 1 and 2, we have one inductor. Direction of current is downward here. Okay, this is node 1 here and this one is node 2. Now between node 1 and 2 there is one resistor connected in parallel. Okay, and direction of current is downward. Okay, like this. And similarly, one more branch is there between node 1 and 2, that is this one. Okay, voltage source connected in series with inductance. So I am representing like this. Current flowing through this one is upward. Okay, now let us consider this one as branch 1. Okay, now branch 2 here is, see, he has given current to this one is I2, so current flowing through this one would be I1. So I am considering this one as branch 2 and middle one is branch 3. Now if you see tie-set matrix, now what is tie-set matrix? Tie-set matrix is drawn between number of loops into branches as columns. Okay, rows is equal to number of loops, columns is equal to number of branches. If you see here, there are 3 branches, so B is equal to 3. Number of nodes is equal to 2. Now number of links L is equal to B minus N plus 1. So this is 3 minus 2 plus 1, which is equal to 2. So the tie-set graph, the tie-set matrix is 2 by 3 matrix. Okay, now consider 2 loops here. Okay, this branch 3 is nothing but in quick we have. There are 2 loops, that is 1 and 2. Okay, now this is loop 1, this is loop 2 versus branch 1, branch 2 and branch 3. Okay, now consider loop 1 here. Okay, this is 1, 2 and this one is 3. Now after marking these matrices, okay, now if you see here loop matrix is drawn in terms of voltage drop in a loop. Okay, now consider here direction of current like this. Okay, this is the direction of current. We have to consider in terms of loop direction always. Okay, similarly here direction of loop current is like this. Okay, in terms of length. Now if you see here, this is loop 1 and this one is loop 2. Now mark the values of this loop matrix. Okay, if loop current is in the same direction of branch currents, take it as +1, and if loop current is opposite to that of branch direction of currents, take it as -1. Okay, now if you see here in loop 1 we have only 1 and 3 branch, so loop 2 should be 0. Okay, and direction of current in with respect to branch 1 is same, so it is 1. Similarly, direction of loop current with respect to branch 2 is same, so this is also 1. So 101 is the first loop matrix we have. Okay, now consider second loop. Second loop we have only 2 and 3 branches, so loop 1 entry should be 0. Okay, Now consider here loop current direction, which is in clockwise. It is same as direction of current in branch 2. So it is plus 1. Similarly, now loop matrix is here opposite to that of branch current 3. So this is minus 1. So answer is option D.
Is an amplifier without feedback gives a fundamental output of 36 with 7% second harmonic distortion when the input is 0.026 volts. If beta equals to 1.2%, that is 1.2% of the output is feedback to the input and a negative voltage series feedback, means the feedback voltage is added to the input voltage. What is the output voltage? Here beta equals to Vf by V0, that is 0.012. Vf is nothing but 0.012 into 36, that is 0.432 volts. Now Vn is, I told you already, in negative voltage series feedback means that is feedback voltage is added to the input, that is 0.432 plus 0.026, which is equals to 0.458. AF is nothing but A by 1 plus A beta, which is equals to 1384.6. So divided by 17.61, which is equals to 78.6. So V0 is equals to 35.99 volts. Hence option D is correct. An amplifier without feedback gives a fundamental output of 36 volts with 7% second harmonic distortion when the input is 0.026 volts. If the fundamental output is maintained at 36 volts but the second harmonic is reduced to 1%, what is the input voltage? See, after feedback the second harmonic distortion is reduced by 1, that is second harmonic distortion is reduced by 1 plus A beta times. Okay, means initial second harmonic distortion is 7%, that is 7 by 100 divided by 1 plus A beta equals to, after reducing it is 1 by 100, means 1%. This 100 cancel, 1 plus A beta equals to 7, means AF equals to A by 1 plus A beta, which is equals to 1384.6 divided by 7, okay, which is equals to 1384.6 divided by 7 equals to 197.8. Here we know that this is V0 by Vs. We know V0 is 36 volts, so Vs is 36 divided by AF, which is equals to 182 millivolts. Hence option A is correct. Consider the following oscillator circuit shown in the ideal op-amp. Determine the frequency of oscillation. See, from the circuit shown in the question, we came to know that this is a Wien bridge oscillator using an op-amp. So for Wien bridge oscillator using an op-amp, the frequency of oscillation is given by 2 pi R1 C1 R2 C2, whereas this is R1 C1 C2 R2. If we substitute the given respective values, we will get F0 as a 472 kilohertz. Hence option B is correct. Here in the above circuit, the value of R1 needed to maintain the oscillation. See, now the condition for oscillation is, suppose if we assume this resistance is R2, this resistance is R1, R2 must be 2R1. That is, here R2 is 10K, 2R1 means R1 is 5K. Hence option B is correct.